Thanks for watching this screencast. The objective of this screencast is learners will be able to determine the slope of a linear function given a table of values. Okay, here's an important definition. So we've been talking about functions lately, and we say that any function is a linear function. You know, the word linear looks like the word line. Any function is a linear function if the y value increases or decreases by the same amount every time, important part of the definition, every time the x value increases by 1. So below at the bottom of the screen are 3 different examples of linear functions. And I want to show you briefly why each one is linear. This first function is a function given as a table. It's a function because every x has only one y. And I see a pattern in the x's, that every time I add 1 to the x, to get from 1 to 2, or from 2 to 3, or from 3 to 4, every time I increase x by 1, I can increase y by the same amount, 3 in this case, from 2 to 5, from 5 to 8, from 8 to 11. So this is one example of a linear function. Now the graph here in the middle is the graph of a function that is also a linear function. It's a function because it passes that vertical line test. Every x has only one y. And here's how I know it's linear. If I take each point, I didn't pick out all the points on the graph. I just picked out the ones that have integer x values. But if I look at those, if I look at the point -2, 6, and I increase the x by 1, each time I increase x by 1, I'll do them all real quick. Each time I increase x by 1, I can decrease y by 2. So I can see on the graph that for every x increased by 1, y is decreasing by the same amount. This is also linear. This third example is kind of weird because the y isn't changing as I increase x by 1. Plus 1, plus 1, plus 1. But that change not changing is still the same. Every interval, the y is changing by 0. So even though the line here goes straight across horizontally, it's a linear function too. That's the definition of a linear function. If every time x increases by 1, y increases or decreases by the same amount, the function's linear. Now we can generalize this by talking about the slope of the function. For a linear function, the slope, which is also called the rate of change, is the same for any 2 ordered pairs in the function. Any 2 points I choose to calculate the slope between in a linear function, I should get the same slope. Now there are a lot of different flavors of the definition of slope that we'll use throughout the coming days. So the slope of a linear function is, and this one right here is the one that I use most often, and it might involve you understanding what the triangle means when you see it in a science or a math class. That's actually the capital Greek letter delta. And when you see the capital Greek letter delta, which looks like a triangle, in a science or math class, that usually means change. So when I talk about delta y and delta x, what I actually mean when I talk about delta y is I actually mean the change in x. How much does x change by from point to point? When I talk about delta y, I'm talking about the change in y. So one way to think about the slope of a linear function is just how much does y change by every time over how much does x change by every time. We'll talk about some more of these different flavors of the same definition later on in the learning target. This is the one I want to roll with today. So our goal in the screencast is to take a linear function given as a table and determine its slope. So the instructions here say for each function below, determine if the function is linear. If so, find the slope. So let's look at this linear function on the left here. It's in a table. To see if it's linear, I want to make sure that the rate of change, the slope is, I'll write it here again. The slope is the change in y over the change in x. So what I want to calculate is I want to see if that slope, that change in y over change in x, will always be the same. So in this linear function, let me look at my x column. And do I see a pattern to get from row to row in the x's? Yeah, I can add 1. Add 1 to -3 to get -2. Add 1 to -2 to get -1. Add 1 to -1 to get 0. Add 1 to 0 to get 1. Do I also have a pattern in the y column? It looks to me like I can do -3 each time. 8 minus 3 is 5. 5 minus 3 is 2. 2 minus 3 is -1. -1 minus 3 is -4. So is it linear? Do I get the same change in y over change in x each time? Yeah. So the slope is, well, what is the slope? Well, it's -3, the change in y, over +1, the change in x. Now, unless there's a really good reason not to, I want to write the slope in simplified form. So a fraction really means division. -3 divided by +1 is just -3. And that's the best way to write my answer. Let's take a look at this linear function here on the right, or at least I hope it's linear. We're going to find out. In the x column, is there a pattern to get from one x value in each ordered pair to the next? This time it's not +1, it's +2. And that changes slightly our definition of is it linear or not. But we can expand that to say that as long as the slope is the same between any 2 points, it's linear. Is there a pattern in the y column? Well, this also looks like +2. I can add 2 to 1 to get 3. 3 plus 2 is 5. 5 plus 2 is 7. 7 plus 2 is 9. So what's my slope? Well, it's the change in y, +2, divided by the change in x, which is also +2. Now here's a good example where I don't want to leave my answer like 2 over 2, because I can simplify 2 divided by 2. 2 divided by 2 is 1. The slope of this function is 1. Okay, here are 2 more examples. We'll try the same problem. Is it linear or not? And if it is, let's find the slope. Let's look here in this linear function, or at least in this function. Let's look at the x's and see if we can find the delta x's. It looks like +1. Is it +1 everywhere? It works there. It works there, and it works there. Let's look at the change in y then. What would you add to -4 to get 1? I think it's 5. 1 plus 5 is 6. 6 plus 4 is 10. 10 plus 5 is 15. We've got a problem. And it's right here in the change in y between the third and fourth order pairs in this function. If I thought about putting delta y over delta x, it wouldn't always be the same, would it? So this is not a linear function. Why? Well, because delta y over delta x isn't always the same. I have to be able to say that no matter which ordered pairs I pick, that ratio is the same, or it's not linear. Let's look at this last example over here. This is a little bit different too. How do I get from 6 to 2? I need to subtract 4. There's nothing that says that in your table the entries have to go from least to greatest as far as x's go. 2 minus 4 is negative 2. Negative 2 minus 4 is negative 6. Negative 6 minus 4 is negative 10. We've got the same delta x everywhere. Do we get the same delta y? How do I get from negative 11 to negative 8? I need to add 3. Negative 8 plus 3 is negative 5. Negative 5 plus 3 is negative 2. Negative 2 plus 3 is 1. Well, delta y over delta x is the same. So for this one, my slope is positive 3 over negative 4. Now here's where I need to tell you something about the way that we'll usually write a slope if the fraction has different signed numerator and denominator. So 3/4 is not a fraction that reduces. There's nothing that goes into 3 and 4 other than 1. But the signs are different. So if I divide these two numbers, I'm going to get a negative as my slope. If the signs of the top and bottom of my slope fraction are different, my answer should have a negative out front. This is best written as negative 3/4. And that's what we want you to try to do. Okay, these last two examples are for you. What we'd like you to do now is to pause the video, see if you can calculate the slope of each function if it's linear. If it's not, say it's not linear. And then when you think you've got the slopes calculated, hit play to get some feedback. Okay, let's check it out. For the first function here, it seems to me like a pattern to get from each row of the x's to the next is plus 1. So I think my delta x is going to be plus 1. Is there a rule to get from the row to the next row in the y's? I think it's negative 6. Is it always negative 6? 2 minus 6 is negative 4. Negative 4 minus 6 is negative 10. Yes, it is. So my slope is simply negative 6 divided by positive 1. And what's a better way to write negative 6 divided by 1? Just negative 6. For this function, I think my delta x is, let's see, plus 3 again. Negative 2 plus 3 is 1. 1 plus 3 is 4. 4 plus 3 is 7. I think the rule here is subtract 4. 100 minus 4 is 96. 96 minus 4 is 92. 92 minus 4 is 88. 88 minus 4 is 84. So what's my slope? Well, it's negative 4 over positive 3. And here's another example where the signs are different. So my slope should be written as a negative something. The fraction 4/3 does not reduce. How about 4/3? Thanks for watching.